NASA has a new vision for space exploration. In the decade ahead, humans will travel to the Moon, to Mars, and beyond to further our knowledge of where we fit in the universe. This knowledge gain will also continue to improve our quality of life. The NASA Glenn Research Center at Lewis Field, located on the western edge of Cleveland Hopkins International Airport, is in a strong position to help turn this vision to reality. Established in 1941, Glenn has a rich history in advancement of aerospace research, including in-space propulsion, avionics, communications, and power management and distribution. The highly successful Centaur upper stage vehicle is just one example of the significant contributions Glenn's combined efforts have produced. One piece of this quality infrastructure is Glenn's Power Systems Facility, or PSF. Originally built in 1989 to support the Space Station Freedom program, PSF expanded to support both the new ISS configuration as well as the Fluids and Combustion Module facility utilized on the ISS. PSF and its facilities, including 576,000 cubic feet of Class 100,000 clean room, represents a significant capacity for systems integration, assembly, and test of flight hardware. To support the design, fabrication, and testing of the complete ISS power systems, PSF has test cells for avionics, fuel cells, power electronics, and solar dynamics, as well as additional shop and support rooms. For added support, the two buildings to the southwest of PSF house an acoustics lab and an electromagnetic interference facility for testing of flight hardware. Additional features of PSF include a telescience support center, co-located among its ample office space on the north side of the building. Easy access for transport is assured thanks to PSF's existing shipping and receiving area. The Universal Test Bed, or UTB, building on Glenn's experience, will be used to support all future NASA power system developments to support the exploration initiatives. Future space power systems will utilize voltage from 28 volts to kilovolts and power capacity from kilowatts to megawatts. Safety and reliability will be critical for all of these systems. The UTB is housed in the High Bay West area of the PSF and has existing shop space, as well as being a 100,000 class clean room. Access to the High Bay East area is located through a shop area below a removable floor. The installation of this floor will add another 4,800 square feet of shop and support space. This space would allow for the inspection of incoming equipment and the buildup of small assemblies prior to installation in the service module. The mezzanine can be installed without building modification, using spreaders to dissipate loads, calculated to be well within the limits of the existing floor. The area will be lit and have ample cabling trays for the power, data, and other utility needs. Ready access to the upper area for large equipment is augmented by a set of retractable floor panel doors. These doors provide the necessary seal for cleanroom operation above the doors. In addition to maintaining its Class 100,000 cleanroom status, the upper floor of High Bay East is currently equipped with a 20-ton crane. It is here that the service module assembly and test jig will be housed. The jig and the access stairs leading to it will be movable by means of an air cushion or similar concept. The jig in this animation is patterned after the successful designs used in support of the Apollo mission. The projected 3 levels of flooring are comprised of pedals. When extended, these pedals provide working access to the various panels of the service module. When it's time to transport the module, the pedals can be stowed in the retracted positions, and the entire jig is moved apart to expose the module. The service module can be extracted from its jig and lowered directly onto the waiting vehicle, which will hold the transport container. There is ample room for the semi and trailer to back into the facility and receive the service module. To facilitate the placement of the module into its container, the trailer can be slowly moved forward. The existing 20-ton crane in the High Bay West area will also facilitate this transfer. The proposed layout will allow for the maintenance of clean room requirements from day one through packing. PSF's location and that of the Glenn Research Center as a whole provides access for the ingress and egress of large flight components, such as flight-ready service modules. The proposed transport route passes out of Glen through the western gate and follows a 5-lane road towards the jetway at the International Exposition Center, known as the IX Center. Both the route and pad at the IX Center are more than capable of supporting the necessary loads. The loading location and the route thereto have been chosen to provide maximum ease of egress while minimizing any disruption to both air and land traffic. This ready access to Hopkins is a significant advantage over other potential locations in the U.S. for service module assembly. It is, however, just one of many reasons for Glen to play host to the new service module assembly and integration. In addition to being a convenient and amply large area, The pad at the IX Center has played host to the world's largest transport aircraft, the Antonov 224. The transport of the service module is predicted to require something along the line of the Airbus 300-600 ST Super Transporter, a much lighter craft than the Antonov. As seen here, NASA Glenn has the right combination of facilities, access, and expertise required for the integration, assembly, and test of the new service module.